Welcome to the Journey Shake Chem. Well, please do the 2 warm-up questions to the best of your ability, and we'll discuss them in a moment. Number 1 is asking for the molarity of the aluminum ions and the sulfide ions. Now, in order to determine that, we must first determine the molarity of the solution of aluminum sulfite to begin with. Now, I have 22.6 grams of the aluminum sulfite, and I must change my grams to moles, because molarity is moles per liter of solution. And therefore, 1 mole of aluminum sulfite, and I'm going to need to add up the AMUs. And there are 2 aluminums, which is 2 times 27.0. There are 3 sulfurs, which is 3 times 32.1. And there are 9 oxygens, which is 9 times 16.0. And you remember that we do this again because oftentimes this is where the mistakes come in. And 144.0. We add those numbers up, and we get 294.3 grams per mole. And when I do the math here, I'm going to get 0.07679 moles. And then I must divide it by the volume of the solution in liters. Well, I have 750 milliliters, and 1 liter is 1,000 milliliters. And when I do the math here, I'm going to get 0.1023. I want 2 significant digits in my final answer, and even though this is not my final answer, it's a number I'm going to be using in my other answers. Therefore, I have 0.10 molar of the aluminum sulfite. Now, aluminum sulfide is a strong electrolyte, and therefore it will dissociate 100% into its ions. And I will get 2 aluminum ions with a +3 charge and 3 sulfide ions with a -2 charge. Well, this is all based on the ratio. We have a 0.10 molar solution originally, and there is twice as much aluminum ions, and therefore we have 0.20 molar and 0.30 molar. It is determined by the coefficients. This is my aluminum ions, and these are my sulfite ions. This concept will become very, very important in our next topic as well. So we're learning it now so that we're comfortable with it in the next topic. And that's how you do number 1. It is very important when we are given a concentration, whether it is molarity or molality, that we first write what we're given. Well, here we are given 0.54 molar. Well, what does that mean, 0.54 molar? It means that we have 0.54 moles of the solute for every 1 liter of the solution. And in order to understand this term, oftentimes students just want to use moles here, and this big capital M or even the small m is not mole. It is not moles. Therefore, it is very important to write this. Now then I look at what else am I given in this problem. I'm given the number of moles that I'm looking for. And I'm given 0.005 moles, and my unknown is the volume of the solution. And then I cross multiply and do the math. Let's do this math together. 0.454 mole X equals 0.005 mole liters. And then I need to divide by 0.54 moles in order to get my X and isolate my unknown. And oftentimes students have difficulty with the proper arrangement here and dividing by the proper number. And when I do this, I get 0.00 0.09259 liters. I look back to my original problem, and I need two significant digits, and that would be 0.0093 liters is what would be required to get that number of moles. And on the quiz, remember it's multiple choice. Both the test and the quiz have multiple choice questions. And I may ask for you to make a conversion here to centimeters cubed or to meters cubed or to milliliters. There's a variety of different conversions you could make with this liters. So that's just a little heads up there for you to understand. And also you might want to be taking a closer look at the penguin sheet, because the quiz will be asking for acid, base, acid anhydride, base anhydride, or salts to identify, and also weak, strong, and non-electrolytes. That's 30% of that quiz. And so you may want to take a look at that. Well, I'm sure your facilitator will go over last night's assignment with you, and I can't wait to see you tomorrow. Bye.